Hi students and friends, welcome to my channel. This is Sir AYAZ. In this lesson, I will talk about metallic bonding. Let's see the learning outcomes first. Describe the metallic bonding as the electrostatic attraction between metal ions in a lattice and a sea of electrons. Let's start. Metals and alloys contain metallic bonding. Following are some basic characteristics, properties of metals. All metals exist in solid state except mercury. Mercury exists as a liquid at room temperature and pressure. Mercury definitely have melting point lower than room temperature. Melting point lower than room temperature. Metals are good conductors of heat and electricity. Metals have strong structure, which means they are hard. Metals have high density. Metals have high melting points. Metals are malleable and ductile. Now, if you look at this periodic table, here you'll find metals. Let's draw staircase line first. This is a staircase line. Here we'll find metals. All are metals. And above this staircase line, you will find non-metals. Look at the staircase line. This is the staircase line. And below the staircase line, we have metals only, which means they all are metals. And above the staircase line, we have non-metals. All the metals contain metallic bonding. These are the metals, the group 1 metals, group 2 metals, group 3 metals. Even you are having group 5, 6, 7. You are having metals below these. Whatever the elements present below the staircase line are metals. Or metallic bonding can be defined as electrostatic attraction between positive ions in a lattice and a sea of electrons. A metallic bonding can also be defined as strong force of attraction, strong force of attraction between positively charged metal ions and negatively charged sea of delocalized electrons. Sea of delocalized electrons. And we can represent this metallic bonding through labeled diagram in this way. These are the metal cations. This is the first layer, the second layer, this is the third layer. These are metal ions. And you have delocalized electron. These charged particles are mobile or delocalized electrons. Mobile or delocalized electrons. You see the metal cations and the mobile or delocalized electrons in this structure. This is the metal cation, and we have mobilized or delocalized electrons. These are the mobilized. The particles are metal cations. These are the metal cations. These metal cations form giant metallic lattice. Lattice is a regular, repeated three-dimensional arrangement of atoms, ions, or molecules in a metal or other crystalline solid. Let me write here. Lattice is a regular, repeated three-dimensional arrangement of atoms, ions or molecules, ions or molecules in a metal or other crystalline solid. But how these metals form giant metallic lattice? Metals have tendency to lose their electrons, valence one, to form positive ions. As atoms of metals are closely packed together, the outermost valence electrons become delocalized. You see, delocalized, these are the delocalized electrons. And these free valence electrons act like glue, bonding the metal ions together in the layers. Number of mobile or delocalized electrons depend on the group number. For instance, group 1 have one valence electron. Group 2 has two valence electrons, and so on. In this video, I will talk why metals exist in solid state and hard with high melting points. All metals exist in solid state except mercury, which means metals have high melting point. It is high due to strong metallic bonding. Let me write strong metallic bonding throughout the lattice. Hard to break bonds. Hard to break bonds. Or you can write need a lot of energy. Need a lot of energy to break bonds. Metals have strong structure, which means they are hard. Metals have high density. Again, this is due to strong metallic bonding throughout the lattice. Strong metallic bonding through out the lattice. Also, metal atoms are closely packed together. Closely packed together. Again, we will write that hard to break bonds. Hard to break bonds, or need a lot of energy to break bonds. In summary, metallic bonding can be defined as electrostatic attraction between positive ions in a lattice and a sea of electrons. Metals exist in solid state. Metals have high melting points. Metals are hard. Metals have high density. Thanks for watching. Please like, subscribe, and share my video.